Hello, we're Pink Void and we worked on subsurface void detection. Specifically, we were investigating technologies capable of detecting voids up to 40 feet deep in an open pit mining situation.
So through our research, we came across DAS, or distributed acoustic sensing, which requires the researchers to lay several hundred meters of fiber optic cable along the ground and impact the ground and send a vibrational wave through the earth. The DAS software can record the backscatter, and through analysis, we can pinpoint locations in the earth where the ground density changes drastically. And this is a very strong indicator of a void, as open air and earth and material are a very different density point. Certainly, we did some testing with this technology, but we certainly recommend going farther with this analysis. And we would like to see more testing with this equipment done in the future for the application on mine sites.
So there are two types of signals that are important here when probing the fiber optic cables. The first is a laser pulse that is set along the fiber optic cable, and the second is an acoustic signal which is manually generated along the cable at lengths of 5 meters. The brightest spots on these images correspond to where the acoustic signal was manually generated with a sledgehammer. And the acoustic signals, as they travel along the fiber optic cable, will cause mechanical stresses on the cable, which will affect how the backscatter from the laser actually propagates. And then if we go back and run some DSP algorithms, we can confidently identify where voids are located and at what depth. That is what we would recommend for a continuation of this project. These are just the raw signals in Python without any DSP having been done on them.
So sensors are another technology that can be used to detect subsurface voids. Sensors and cameras have been used in research studies and have been proven highly accurate. Because of inaccessibility and safety concerns, instead of using the sensors as handheld pieces of equipment, we looked at their effectiveness when attached to drones and robots. Some benefits associated with drones and robots are that they can quickly cover large areas and they can be used for more than just void detection. They can go into areas where it's either unsafe or impossible for humans to reach. Using drones to detect subsurface voids poses some challenges, such as the difficulty of underground flight. The major limitation of robots is that they are dependent on the qualities of the voids. This can be an advantage if the conditions are known, but if they are unknown, it could be expensive to have a different robot for each possibility. Overall, we're proud of our work with the fiber optic DOS system, and we're excited about the potential of drones and robots in underground void detection.